So the proof on the review of Learning Target 5.8. I tend to start my proofs, as I've said before, on what I'm trying to prove. So I'm trying to prove that this is a parallelogram, which means this is the last thing on my sheet. Now, to be a parallelogram, think about the definition of a parallelogram. It is a quadrilateral with both pairs of opposite sides being parallel. So opposite sides have to be parallel. So to be a parallelogram, it has to be a quadrilateral. That's given. But in order to use the definition of a parallelogram and know it's a parallelogram, I'm going to have to show that those opposite sides are parallel. The only way that we have this year so far to show that two lines or two segments are parallel is if, when I look at those lines and they are cut by a transversal, I have either alternate exterior angles, corresponding angles, or alternate interior angles that are congruent to each other. Well, I've got angle 1 and angle 2 here. If I can show that they are congruent, then I can use the converse of the alternate interior angles conjecture to say that JK and ML segments are parallel. So somehow I'm going to have to show that these two angles are congruent to show then, if they're congruent, then the lines are parallel. Same thing on the one below it. The only way I can show that those two angles are congruent, because I can't use that the sides are parallel, that's what I'm trying to prove, is to be able to use CPCTC. Well, the only way that I can use CPCTC is to have congruent triangles before that. So let's go back and say, well, then somewhere the other part of the given has to come into play. So they already showed me in the given that JM and KL segments are congruent to each other. So that's going to be one of my given statements. They also showed me that side JK and side ML are congruent to each other, because that's part of my givens. Well, I also know, because it's the same segment, that JL is congruent to itself. Now, these three together, if I know all three of these, then I can say this, which is why the arrows are doing what they're doing, and I can say it because of side, side, side. If I know that those two triangles are congruent, then I can say this pair of angles is congruent because of CPCTC. If I know these are congruent, I can say this. The arrows, the box at the front of the arrow is the if. The box after the arrow is the then. If I know these angles are congruent, then I can use the converse of the alternate interior angles conjecture to say this. This is my proof.